Welcome, and thank you for being here. You found this place at just the right time. Whether the day was long or busy, or simply one of those days that asked a little too much of you, this moment is yours now. This is Sleepy Science, and tonight we are going somewhere extraordinary. Not across a road or over a mountain or into the next town, but outward. Across distances so immense they have no name in our everyday language. Tonight, we are going into the nebulae, the glowing clouds of the universe. The great colorful nurseries and graveyards and wonders of the cosmos that drift in the space between stars, like something half remembered from a beautiful dream. You do not need to stay awake for any of this. In fact, the whole point is that you don't. These words are here to carry you, slowly, gently. Like the wind moving through the veil of a great cosmic cloud, millions of light years from anywhere, unhurried and soft, and always, always drifting. So settle in. Let your body feel heavy where it rests, and let your breath begin to slow. We have a long and beautiful journey ahead of us, and there is no rush at all. Let us begin. The word nebula comes from the Latin word for cloud or mist. It is a fitting name. When the earliest astronomers turned their telescopes toward the sky and discovered faint, hazy patches of light that were not stars, they needed a word to describe what they were seeing. And cloud felt right. Because that is exactly what a nebula looks like through the lens of a telescope. A soft, glowing smear of light. A mist suspended among the stars. Something without hard edges, without a single fixed center, spreading outward in all directions like smoke from a fire that burned a very long time ago. In the earliest days of astronomy, the word nebula was used for almost anything that appeared fuzzy in the night sky. Distant galaxies, star clusters, and actual clouds of gas were all lumped together under this one soft word. It took centuries of observation and eventually the invention of more powerful instruments before astronomers began to understand what each type of nebula actually was. Some were galaxies, so unimaginably far away that their billions of individual stars blurred into a single smudge of light. Others were true clouds, enormous drifting collections of hydrogen and helium and fine cosmic dust, hanging in the space between the stars of our own galaxy, sometimes so vast they stretched across hundreds of light years. And it is those true clouds, those genuine nebulae, that we are exploring tonight. They are not distant galaxies. They are the living, breathing, slowly swirling interior of our own Milky Way. Our cosmic neighbors, our home territory. And they are among the most beautiful and strange things the universe has ever made. Most of what a nebula is made of is hydrogen. This might seem like a simple fact, and in a way it is. But when you sit with it for a moment, it becomes something quietly astonishing. Hydrogen is the simplest element in the universe. One proton, one electron, nothing more. It was the first element to form after the Big Bang, when the universe was young and hot and only a few 100,000 years old. hydrogen flooded the cosmos like a primordial sea. And in the billions of years that followed, it became the raw material out of which almost everything else was made. Stars are mostly hydrogen. The water in the oceans of this planet is 2 parts hydrogen. The human body is about 10% hydrogen by mass. And the great glowing clouds of the nebulae, drifting through the galaxy in silence, are mostly hydrogen too. Mixed in with the hydrogen is helium, the second simplest element. There are trace amounts of other things as well: carbon, oxygen, nitrogen, sulfur, and fine grains of dust made from these heavier elements. Remnants of stars that lived and died before our sun was ever born. But mostly, it is hydrogen, the simplest thing, in unimaginable quantities, spread across unimaginable distances. There is something peaceful in that. I think that the universe, in all its complexity and strangeness, returns again and again to the simplest possible beginning. Just hydrogen, just space, just the slow, patient work of gravity and time. Nebulae come in several different types, and each one tells a different kind of story. The most famous type is the emission nebula. An emission nebula glows with its own light. This happens when the gas inside it is energized by the intense ultraviolet radiation pouring out of nearby hot young stars. When that radiation strikes the atoms of hydrogen in the cloud, it knocks electrons loose from their atomic homes. And when those electrons eventually find their way back, they release light as they settle. Different elements release different colors. Hydrogen tends to glow in deep shades of red and pink. Oxygen produces a cool, blue-green hue. Sulfur contributes warm oranges and reds. The result, when you layer all these colors together, is something that looks less like a scientific phenomenon and more like a painting made by someone who had access to colors we don't have names for yet. The famous photographs of nebulae, those breathtaking images you may have seen of towering pillars of gas and swirling curtains of color, are mostly emission nebulae. Their glow is real. Their colors are real. They are just stretched across distances so enormous that no human being will ever stand close enough to see them with their own eyes. Then there are reflection nebulae. These clouds do not produce their own light. Instead, they shine because they are sitting near a star and reflecting its light back into space, the way a fog bank glows faintly when headlights sweep through it at night. Reflection nebulae tend to appear blue because blue light scatters more easily off the tiny dust particles in the cloud than other colors do. It is the same reason our own sky is blue during the day. The physics of light and scattering operating at a scale we are familiar with, just stretched across light years instead of miles. And then there are dark nebulae. These are clouds of gas and dust so thick and dense that they block the light of everything behind them. They do not glow. They do not reflect. They absorb. Dark nebulae appear in photographs as strange, shadowy shapes. Black voids cut out of the star field like pieces missing from a puzzle. Some of them have striking silhouettes, identifiable shapes that have earned them names over the generations of astronomers who studied them. The Horsehead Nebula is one of the most iconic. It appears as a dark, horse-shaped pillar rising against the reddish glow of the Emission Nebula behind it, like a chess piece made of shadow. There are also Planetary Nebulae, which, despite the misleading name, have nothing to do with planets. They form when a star like our own Sun reaches the end of its life and gently sheds its outer layers into space. The result is a soft, glowing ring or bubble of expelled gas surrounding the small, dense remnant of the star at the center. They were named planetary nebulae by early astronomers because through small telescopes they resembled the round, disc-like shapes of planets. The names stuck, even though we now know exactly what they are. And finally, there are supernova remnants. The expanding shells of gas and energy thrown outward when a massive star ends its life in a catastrophic explosion. Each type of nebula is a different chapter in the same great story of how matter and energy cycle through the universe. Stars are born in nebulae. Stars die and become nebulae. The material from those nebulae drifts through space until gravity gathers it together again, and new stars are born. It is an endless cycle, patient and vast and quietly magnificent. The Orion Nebula is the most observed nebula in the sky, and it is visible to the naked eye on clear nights. This is an extraordinary fact when you consider what it actually is. The Orion Nebula sits about 1,344 light-years from Earth. 1 light-year is the distance light travels in a full year, moving at nearly 300,000 kilometers per second. Do that for 1,344 years, and you have the distance between us and the Orion Nebula. And yet, on a clear winter night, if you find the constellation of Orion with his distinctive 3-star belt, and then look at the region just below that belt where his sword hangs, you will see what appears to be a slightly fuzzy star. That fuzziness is the Orion Nebula. Not a star, not a smudge on your glasses. A cloud of gas and dust 40 light-years across, actively forming new stars as you look at it, more than 1,000 light-years away. Through a small telescope, the Orion Nebula reveals itself as a breathtaking structure. A greenish-gray glow of gas, with 4 brilliant young stars at its heart. These 4 stars, known as the trapezium, are some of the youngest and brightest stars in our part of the galaxy. They formed from the very cloud that surrounds them, and their intense radiation is what makes the nebula glow. Inside the Orion Nebula, astronomers have found what are called protoplanetary disks. Flat, rotating clouds of gas and dust surrounding young stars that have not yet finished forming their planetary systems. These are, quite literally, solar systems in the process of being built. Worlds being assembled right now. While you lie here in the quiet, dark, breathing slowly, the Orion Nebula is still at work. Still making stars. Still spinning up the raw material of future worlds from a cloud of simple gas and ancient dust. It has been doing this for millions of years, and it will keep doing it for millions more. Steady, patient, unhurried. Rather like the way sleep comes to those who let it. The Crab Nebula is the remnant of a star whose explosion was recorded by human observers nearly 1,000 years ago. In the year 1054, astronomers in China noticed something unusual in the sky. A new star had appeared, visible even in the daytime for several weeks. It was so bright that some accounts suggest it outshone everything in the sky except the sun and the moon. What those ancient sky watchers were seeing was a supernova, a massive star, tens of times the mass of our sun, reaching the end of its life and exploding with a violence almost impossible to comprehend. The explosion briefly released more energy than our sun will emit over its entire 10 billion year lifetime. Today, nearly 1,000 years later, the expanding shell of gas from that explosion is still spreading outward through space. We call it the Crab Nebula, and it sits about 6,500 light-years away in the constellation Taurus. It is a tangled, glowing web of filaments, threads of gas still rushing outward at over 1,500 kilometers per second. Its structure is chaotic and intricate, like the threads of a great tapestry that has been torn apart and is still flying through the air. At the center of the Crab Nebula sits a pulsar, the dense, incredibly compact remnant of the star that exploded. This pulsar is roughly 30 kilometers across, about the size of a city, yet it contains roughly 1.5 times the mass of our entire sun. It spins 33 times every second, sending out beams of radiation like a cosmic lighthouse. The Crab Nebula is one of the most studied objects in the entire sky. It has been observed across every wavelength of light we know how to detect. In radio waves, in infrared, in visible light, in X-rays, in gamma rays. And in each wavelength, it reveals a different layer of the same story. The story of a star that lived for millions of years, burned brilliantly, and then, in a moment that human beings happened to witness, became something entirely new. Not gone, just transformed, still spreading outward, still glowing, still telling us what it once was. Nebulae can be unimaginably large. When we talk about size in everyday life, we use measurements that feel real to us. Meters and kilometers, the length of a room or the distance between two cities. But the sizes of nebulae stretch so far beyond these familiar scales that the numbers stop feeling like numbers and start feeling like something else entirely. The Orion Nebula, which we discussed earlier, spans about 40 light-years across. That means light, traveling at its incredible speed, takes 40 full years to cross from one side of the nebula to the other. But the Orion Nebula is small compared to some. The Tarantula Nebula, located in a small galaxy called the Large Magellanic Cloud that orbits our own Milky Way, spans about 1,000 light-years across. It is so large that if it were located in the same position as the Orion Nebula, it would cover a significant portion of our sky and would be bright enough to cast shadows on the ground at night. And the Tarantula Nebula is not even the largest we know of. There are diffuse nebulae, vast and loosely structured, that span many thousands of light-years. The Carina Nebula spans roughly 300 light-years. The Rosette Nebula is about 130 light-years across. And then there are the truly enormous structures, the great molecular clouds, cold and dark and immense, that can stretch across hundreds or even a few thousand light-years. The human mind was not built to hold these distances. And maybe that is all right. Maybe we do not need to fully understand these scales in order to feel something about them. The way you do not need to understand acoustics to feel moved by a piece of music. Some things are large enough that simply knowing they exist is enough. The nebulae are out there right now, drifting in the dark between the stars, enormous beyond our imagining, and completely indifferent to the hour, or to whether any small creature on a small blue planet is asleep or awake. They just drift. And tonight, so can you. Not all nebulae are places of birth. Some are the final expressions of stars that have reached the end of their lives. When a star like our Sun runs out of hydrogen in its core, something profound begins to happen. The core, no longer able to sustain the nuclear fusion that has been holding it together against the pull of gravity, begins to contract. As it contracts, it heats up. And that heat causes the outer layers of the star to expand dramatically, swelling outward into space until the star is dozens or even hundreds of times larger than it once was. This is the red giant phase. Our own Sun will enter this phase in roughly 5 billion years. When it does, it will expand far enough to swallow Mercury, Venus, and possibly the Earth. But eventually, even the red giant phase ends. The star's outer layers, held only loosely by the dying star's weakened gravity, begin to drift away into space. They spread outward in great shells and rings, glowing as they are energized by the hot remnant of the star at the center. This is a planetary nebula, and they are, in my estimation, some of the most beautiful objects in the known universe. The Ring Nebula in the constellation Lyra is a classic example. It appears as a soft, glowing loop of light, like a smoke ring blown by some unimaginably large creature and left hanging in the dark. At its center, barely visible, is the white dwarf, the hot, dense remnant of the star that once was. The Helix Nebula, sometimes called the Eye of God, is another stunning example. It is one of the closest planetary nebulae to Earth, about 650 light-years away, and it appears as a vast, circular structure of concentric rings, its blue-green center surrounded by rings of orange and red. From a distance, it really does look like an enormous eye, open and gazing outward from the darkness. The Cat's Eye Nebula is another favorite. Intricate and layered, with concentric shells of gas surrounding a brilliant central region, it looks like something alive. Something that has been slowly breathing outward for thousands of years. And in a way, it has been. A planetary nebula is the last breath of a star, the gentle exhalation of a life that burned for billions of years. There is no violence in it, or very little, at least. It is quiet, slow, spreading, a star letting go. And the cloud it leaves behind will drift through space for tens of thousands of years until the material is eventually absorbed into new clouds, new nebulae, the raw material of new stars and new worlds. Nothing is lost. It only changes form. Stars do not form easily. The clouds of gas and dust that make up a nebula are, by the standards of most things in everyday life, extraordinarily thin. A cubic centimeter of the densest part of a nebula might contain only a few thousand molecules. By comparison, the air you are breathing right now contains about 27 billion molecules in every cubic centimeter. The nebula is, in most of its vast extent, closer to a perfect vacuum than anything we could achieve in a laboratory on Earth. And yet, given enough time and enough space, gravity can work even on material this thin. When a small region of a molecular cloud becomes slightly denser than its surroundings, perhaps triggered by a shock wave from a nearby supernova, or by the gravitational tug of passing stars, or simply by the random fluctuations that govern all matter at the quantum level, that region begins to attract more gas to itself. Gravity is patient. Slowly, over hundreds of thousands of years, a small region of the cloud begins to contract. As it collapses, it heats up. As it heats up, it begins to glow faintly, not from nuclear fusion yet, but simply from the heat of compression. This glowing ball of collapsing gas is called a protostar. It continues to gather material, to grow, to heat up, and eventually, after perhaps another 100,000 years or so, the temperature and pressure at its core become so extreme that hydrogen atoms begin to fuse together to form helium, releasing energy in the process. The star ignites. A sun is born. This process is happening right now in the nebulae scattered throughout our galaxy. In the pillars of the Eagle Nebula, in the depths of the Carina Nebula, in the glowing nurseries of the Orion molecular cloud. New suns are being kindled right now, while you rest. Stars that did not exist this morning, and will not be fully formed for another 100,000 years. Somewhere in the dark between the stars, a protostar is warming, gathering gas to itself grain by grain, molecule by molecule. Patient and inevitable. The universe does not rush, and neither do you. The pillars of creation are perhaps the most famous image ever taken of a nebula. They were first photographed by the Hubble Space Telescope in the year 1995, and the image became an instant icon. Not just in the scientific community, but in the wider culture. You have likely seen it even if you do not know it by name. The image shows 3 towering columns of gas and dust, rising like fingers from a larger cloud. They appear amber and tan in the original photograph, their surfaces sculpted into strange rounded shapes by the intense radiation streaming from young stars just outside the frame. The largest of the 3 pillars is roughly 4 light-years tall. 4 light-years. That is roughly the distance from our own sun to the nearest star system. And it is the height of a single column of gas and dust, a single feature within a single nebula, in one quiet corner of the Milky Way. The pillars of creation are part of the Eagle Nebula, also known by its catalogue designation Messier 16. They are stellar nurseries, regions within the nebula where the dense gas is in the process of collapsing to form new stars. The tips of the pillars, those rounded, lobe-like shapes at the top of each column, are regions of particular density where star formation is occurring. There is a poignant and strange piece of science associated with the pillars of creation. In 2007, astronomers using infrared observations found evidence that the pillars may have already been destroyed by a supernova explosion that occurred roughly 6,000 years ago. But because the Eagle Nebula is approximately 7,000 light-years from Earth, the light from that destruction has not yet reached us. We may be looking at a ghost, a structure that no longer exists, its image still traveling toward us through space, expected to arrive perhaps 1,000 or more years from now. The universe, once again, reminding us that what we see is not always what is. But whether or not the pillars still stand in physical space tonight, their image is here with us. And it is extraordinary. Columns of creation, dark at the base and brighter toward their tips, rising silently in the Eagle Nebula, while you drift towards sleep. The colors we see in photographs of nebulae are real, but not in the way you might think. When you look at a breathtaking image of a nebula, with its vivid reds and blues and greens and golds, you might assume that this is what the nebula actually looks like. And in a sense, it is. But in another sense, the colors have been translated. Many of the most famous nebula photographs are taken using what scientists call narrowband filters. These filters isolate the light from specific elements, hydrogen, oxygen, and sulfur being the most commonly used, and then those separate channels of light are assigned colors for the final image. In a system developed for Hubble telescope images, and now widely used, the light from sulfur is colored red, the light from hydrogen is colored green, and the light from oxygen is colored blue. These are not arbitrary colors. They are chosen to maximize contrast and reveal structure that would be invisible otherwise. The result is scientifically informative, and also, quite incidentally, extraordinarily beautiful. If you were to fly a spacecraft into the Orion Nebula and look around with your own eyes, the experience would be different from those famous photographs. The cloud would be dim, thin, and spread out around you. You might see a faint reddish haze in some directions and darkness in others. The nebula, as we know it from photographs, is a composite image built from long exposures and processed to reveal details no human eye could detect in real time. But here is the thing. The science is real. The structure is real. The gas and dust and newborn stars are all exactly where the images show them to be. The colors are just a translation from a language of wavelengths into a language our eyes can understand. like how a piece of music might represent an emotion that has no direct word in any language. The translation is not the original thing, but it conveys something true, something real, something that matters. The nebulae are both exactly what the photographs show and something altogether different. Both things can be true. Reality is generous like that. There is a nebula that smells of raspberries and tastes of rum. This is not a poetic metaphor. In 2009, a team of astronomers studying a massive molecular cloud near the center of our galaxy, a region called Sagittarius B2, detected the presence of a molecule called ethyl formate. Ethyl formate is responsible for the flavor and aroma of raspberries, and it is also a component in the aroma of rum. The cloud in which it was found contains a vast amount of it, along with many other complex organic molecules. In fact, Sagittarius B2 is one of the most chemically complex environments known in space. It contains molecules like ethanol, the same alcohol found in wine and beer, and amino acids, the building blocks of proteins. The chemistry happening inside molecular clouds is not simple. These vast cold regions of gas and dust are remarkable chemical laboratories, where molecules form on the surfaces of tiny dust grains and then evaporate into the gas phase when exposed to radiation. Over billions of years, the molecules built up inside these clouds include some of the same compounds that are essential to life as we know it on Earth. There is a real and serious scientific question about whether some of the building blocks of life arrived on the early Earth, carried inside comets and asteroids, that were themselves assembled from the material of molecular clouds. Whether the first steps toward life on our planet were seeded from the depths of space. A cloud of gas between the stars, smelling faintly of raspberries, carrying within it the chemical precursors of something that would eventually become eyes and brains and heartbeats. It is a thought worth carrying gently into sleep. Some nebulae hide things inside them. The clouds of gas and dust that make up a nebula are not transparent. The dust, in particular, is very good at blocking visible light, and so the interiors of dark and dense nebulae are hidden from optical telescopes. For a long time, astronomers knew these regions existed, but could not see inside them. Then came infrared astronomy. Infrared light has a longer wavelength than visible light, and it can pass through dust much more easily. When telescopes were developed that could detect infrared radiation, the interiors of dark nebulae were suddenly accessible for the first time. What astronomers found inside was astonishing. Stars. Not just one or two, but sometimes entire clusters of young stars, hidden within the dark clouds, completely invisible to the naked eye and to ordinary telescopes. These hidden stars, called embedded protostars or T Tauri stars depending on their stage of development, are often surrounded by disks of gas and dust from which planets may eventually form. The dark nebula called Barnard 68 is a famous example. It appears in photographs as a perfectly dark oval, blotting out the stars behind it like a hole in the sky. But in infrared, it reveals its interior. Dense and cold and rich with chemistry, poised perhaps on the verge of collapsing into stars. The James Webb Space Telescope, launched in 2021 and operational since 2022, has been particularly remarkable at peering inside these hidden regions. Its infrared instruments can see through the veils of dust that have hidden stellar nurseries for centuries of observation, revealing the young stars within in extraordinary detail. Some of the most memorable early images from Webb showed exactly this. Regions of star formation that had been dark patches in previous images, suddenly alive with dozens of newly revealed young stars, glowing in their infrared warmth behind curtains of dust that Webb could see right through. The universe contains layers, and we are still just beginning to peel them back. Below what we can see, there is always more. Below the dark, there is always light. There is a nebula shaped like a butterfly. The Butterfly Nebula, also catalogued as NGC 6302, is a planetary nebula about 3,800 light-years from Earth in the constellation Scorpius. It gets its name from the two large lobes of gas that extend outward from its center, one to each side, giving the nebula an appearance strikingly similar to the wings of a butterfly in flight. The material in those wings is moving outward from the central star at speeds of roughly 950 kilometers per second. This makes it one of the fastest expanding planetary nebulae known. At the center of the butterfly is a star of extraordinary temperature. Surface temperatures there exceed 220,000 degrees Celsius, making it one of the hottest known stars in the Milky Way. The star is surrounded by a thick ring of dust, which blocks material from expanding outward through its equator. Instead, the stellar material is channeled through the poles, creating the two great lobes that form the wings. In photographs from the Hubble Space Telescope, the Butterfly Nebula is vivid and detailed. The wings are bright at their bases, where the gas is heated, and they fade toward their outer edges into filaments and wisps. There are also regions of darker dust visible within the wings, creating patches and shadows that give the structure texture and depth. A butterfly, made of gas and light, 3,800 light-years wide, drifting in the dark of the Scorpion constellation. The universe has a sense of shape. It arranges things, sometimes, into forms that feel familiar, as if it is reaching out across unimaginable distances and showing you something you might recognize. A butterfly, wings outspread, going nowhere in particular, just floating. The temperature inside a nebula can vary enormously from one region to another. The cold molecular clouds, where stars are just beginning to form, can have temperatures close to absolute zero, just a few degrees above the coldest temperature physically possible. These are among the coldest places in the known universe. At these temperatures, molecules slow almost to a halt. Chemical reactions occur at an extraordinary crawl. A chemical process that might take a fraction of a second in a warm environment might take thousands of years inside a cold molecular cloud. Yet chemistry still happens. Slowly, patiently. On the surfaces of dust grains, atoms and molecules stick together and react, building up complex molecules over vast periods of time. At the other extreme, the gas immediately surrounding a hot young star in an emission nebula can reach temperatures of 10,000 degrees or more. The radiation from the star strips electrons from atoms, creating a plasma of ions and electrons that glows brilliantly. And in the case of a supernova remnant like the Crab Nebula, some regions of the gas have been heated to millions of degrees by the shockwave of the explosion. These regions glow in X-rays, visible only to space telescopes specially built to detect this high-energy radiation. A single nebula can thus span a temperature range from nearly absolute zero to millions of degrees, from one of the coldest environments in the universe to one of the hottest, all within the same cloud. Cold beginnings and hot transformation, coexisting in the same enormous structure. Like the way a single day can hold within it the deep cold of early morning, and the warmth of afternoon, and the cool quiet of night. All temperatures, all states, within the same great drifting thing. The Carina Nebula is one of the largest stellar nurseries in the Milky Way. It lies about 7,500 light-years from Earth, in the southern constellation of Carina, the ship's keel. It stretches across roughly 300 light-years of space and contains some of the most massive and luminous stars known in our galaxy. Among its residents is a star called Eta Carinae, one of the most massive and unstable stars known to science. Eta Carinae is estimated to contain between 100 and 150 times the mass of our Sun. It burns with a luminosity roughly 5 million times greater than that of our Sun. It is so extreme that it sits right at the edge of what theory predicts to be physically possible for a star. In the 1830s and 40s, Eta Carinae underwent a series of massive eruptions, briefly making it the second brightest star in the entire sky. During these eruptions, it ejected roughly 10 to 40 solar masses of material into space. This material forms a twin-lobed nebula of its own, much smaller than the Carina Nebula as a whole, called the Homunculus Nebula, which surrounds the star like a ghostly hourglass. Astronomers believe Eta Carinae is a candidate for a future supernova. When it eventually explodes, it could potentially be briefly visible in daylight from Earth. It has not exploded yet. It may not for another 100,000 years, or it may be exploding right now, and we simply have not received the light yet, separated as we are by 7,500 light-years. The Carina Nebula as a whole is spectacular. The James Webb Space Telescope released an image of its edges in 2022 that became one of the most celebrated astronomical photographs ever taken. It showed a landscape of gas and dust at the boundary between a dense cloud and an open region illuminated by hot young stars. The image was rich with detail. Pillars of gas reminiscent of the pillars of creation. Globules of dense material backlit by the glow of the nebula. And scattered throughout, hundreds of newly revealed young stars that had been hidden behind dust in previous observations. The Webb image of the Carina Nebula looks like a landscape, a mountain range made of gas, a cliff face of cosmic dust, a sky above it filled with brilliant points of light. It looks like somewhere you could go, like a place that might have weather and seasons and tides, like somewhere, perhaps, you might fall asleep under an unfamiliar sky and wake to find yourself inside a story. Our own sun was born in a nebula. This is something worth sitting with for a moment. The sun, which has been the center of our solar system for 4.5 billion years, which has warmed every creature that has ever lived on this planet, which will continue burning for another 5 billion years, was once a cloud of gas. About 4.5 billion years ago, a region of a molecular cloud in the Milky Way began to collapse. Some astronomers think the collapse may have been triggered by a nearby supernova, a shock wave that compressed the cloud just enough to tip it past the point where gravity could take over. As it collapsed, it began to spin. The way a skater pulls their arms in and spins faster, the collapsing cloud sped up as it shrank. The center became denser and hotter. Around the growing protostar, the remaining material flattened out into a rotating disk. Within that disk, particles of dust began to stick together. Over millions of years, dust grains became pebbles, pebbles became boulders, boulders became planetesimals, and planetesimals eventually collided and merged to become planets. The Earth formed from the same cloud that formed the Sun. The iron in the Earth's core, the silicon in its rocks, the oxygen in its oceans and atmosphere, all of it was once gas in a nebula, drifting in the space between stars in our young galaxy. And the iron in your blood, the calcium in your bones, the oxygen in your lungs right now, all of it was once part of a stellar nursery, a cloud of gas and dust not unlike the ones we have been exploring tonight. You are, in a very literal sense, made of nebula. The cosmos did not observe you from the outside. It assembled you from the inside. You are the nebula, thinking. There is a nebula that looks like a skull. The Skull Nebula, catalogued as NGC 246, is a planetary nebula about 1,600 light-years from Earth in the constellation Cetus, the Whale. It is an old planetary nebula, its structure more diffuse and irregular than some younger ones. The gas has been expanding for long enough that it has developed a complex, bubbled appearance, with darker regions where denser material persists, and brighter regions where the gas is more luminous. Two prominent dark patches near the center of the nebula, combined with a slightly elongated overall shape, give it an uncanny resemblance to a human skull. Within the Skull Nebula are not one but two stars. The central white dwarf that created the nebula, and a companion star in orbit around it. This binary system at the heart of the skull slowly illuminates the gas around it, the light from two small stars keeping the old cloud glowing for tens of thousands of years after the main star's death. The Skull Nebula is a pleasant reminder that the universe, while vast and indifferent occasionally arranges its matter into shapes that feel almost personally addressed, like it is winking at you. A skull made of light, floating in the constellation of the Whale. The universe has a quiet sense of humor, if you look at it from the right angle. Some nebulae contain magnetic fields. This is not, perhaps, immediately obvious from looking at photographs of these beautiful clouds. But woven through the gas and dust of many nebulae are tangled, often complex magnetic fields, invisible to ordinary observation, but detectable through careful analysis of the light the nebula emits. These magnetic fields play an important role in star formation. Magnetic fields can slow or even halt the collapse of gas within a molecular cloud, providing a kind of extra support against gravity. Gas flowing along magnetic field lines moves more easily than gas moving perpendicular to them, and this influences the shapes of the structures that form as a cloud collapses. Astronomers study magnetic fields in nebulae by looking at the polarization of light emitted or scattered by dust grains. Dust grains in a nebula tend to align themselves with the local magnetic field, like tiny compass needles all pointing in the same direction. When they scatter starlight, they do so in a way that carries information about their orientation, and this allows astronomers to map the direction and structure of the magnetic field within the cloud. The maps that result are striking. They show field lines flowing through the cloud in great sweeping curves, sometimes following the shape of the overall structure, sometimes cutting across it at unexpected angles. It is like seeing the grain in the wood of a tree, a hidden structure revealed. A nebula is not just gas and dust. It is gas and dust threaded through with invisible lines of force, fields of magnetism stretching across light years, shaping the way matter moves and collapses and eventually forms stars. The invisible structures of the universe are as important as the visible ones. What holds things together is often something you cannot see. The Veil Nebula is the remnant of a star that exploded between 5,000 and 8,000 years ago. It was a bright and violent end. A massive star, much heavier than our Sun, reached the end of its life and exploded as a supernova. The explosion briefly outshone millions of stars, and then the expanding shell of gas and energy began its slow spread outward into the surrounding space. 5,000 to 8,000 years later, that shell has expanded to cover a region of sky about 3 degrees across, roughly 6 times the diameter of the full moon as seen from Earth. The Veil Nebula is located about 2,100 light-years away in the constellation Cygnus, the Swan. In photographs, the Veil Nebula is extraordinary. It appears not as a solid shell, but as an intricate lacework of fine filaments, thin threads of glowing gas stretched and twisted by the shock wave of the original explosion and by subsequent interactions with the surrounding interstellar medium. The filaments glow in the colors of hydrogen and oxygen, deep reds and crisp blue-greens, intertwined into something that looks almost woven, like a curtain of light, like the finest silk pulled thin across the face of the dark. Different parts of the Veil Nebula have different names. The Western Veil, also called the Witch's Broom Nebula, is a long, curved section of the shell particularly bright and well-defined. The Eastern Veil is another section, complementary in shape and, similarly, beautiful. And Pickering's triangle is a fainter region between them, a ghostly web of light that fills the middle of the structure. Together, they form a remnant that spans something like 73 light-years from edge to edge. The star that made the Veil Nebula is gone. What it left behind is this: a curtain of colored light hanging in the constellation of the Swan, drifting slowly outward, growing thinner with every passing millennium, eventually too thin to glow, eventually absorbed back into the interstellar medium from which the original star was born. Death returning to the beginning, matter cycling endlessly through the dark. The Rosette Nebula is a nearly perfect ring of gas surrounding a cluster of hot young stars. It sits about 5,000 light-years from Earth, in the constellation Monoceros, the Unicorn. The Rosette Nebula is about 130 light-years across. Its central hole, the region that appears empty in photographs, was carved out by the powerful stellar winds and radiation pouring from the cluster of young stars at its center. These central stars formed first from the denser regions of the original cloud. As they ignited, their radiation and winds began pushing the surrounding gas outward. Over hundreds of thousands of years, this outward pressure cleared a large cavity in the center of the cloud, creating the ring-like appearance we see today. The edges of the Rosette Nebula are sites of active star formation. The compression of the gas at the boundaries where the stellar winds meet the outer cloud is triggering new collapses, new protostars, new suns being born from the material pushed outward by the first generation of stars. This is a process called triggered star formation, and it is a wonderful example of how one generation of stars can catalyze the creation of the next. The first stars to form in the Rosette are, in a sense, grandparents now, blowing out their winds, filling the region with radiation, and in doing so, inadvertently giving birth to a new generation at the edges of the space they have made. Life making room for more life. Even among stars. Even among clouds of gas 100 light-years wide. Some nebulae travel through space like ships with bows of compressed gas. When a star moves quickly through the interstellar medium, the gas and dust between the stars that surrounds it, it creates a compressed region ahead of it called a bow shock. The interstellar medium is not empty. It is a thin soup of gas and magnetic fields. And when a fast-moving star plows through it, the gas piles up in front of the star, the way water piles up in front of a moving boat. The bow shock glows because the compressed gas is heated and excited by the star's radiation. One beautiful example is the bow shock around a star called Zeta Ophiuchi. This star, about 20 times the mass of our Sun, is moving through space at about 24 kilometers per second relative to the surrounding gas. In infrared images, Its bow shock appears as a graceful arc of warm, glowing gas, curving ahead of the star, like the prow of a ship cutting through fog. Zeta Ophiuchi is thought to have been ejected from a binary star system when its companion exploded as a supernova. The explosion that killed one star flung the other outward at high speed, a runaway star still carrying the momentum from that ancient catastrophe. And as it runs, it glows, the gas piling up before it, creating a subtle, beautiful arc of light. A star with a wake, moving through the dark, alone and still glowing. The Lagoon Nebula is visible to the naked eye on a dark, clear night. Like the Orion Nebula, the Lagoon Nebula is one of those extraordinary objects that bridges the gap between what we can observe directly and the wonders revealed by technology. It sits about 4,100 light-years from Earth, in the direction of the constellation Sagittarius, toward the center of our galaxy. From a dark location, it appears as a faint, fuzzy patch, almost like a smudge of the Milky Way that has been slightly brighter than its surroundings. Through binoculars, you can begin to make out its structure, an elongated glow with a dark lane cutting across it. And through a telescope, it opens up into something magnificent. The Lagoon Nebula spans roughly 110 light-years by 50 light-years. It is an active star-forming region, containing several young star clusters embedded within the cloud. Within the Lagoon Nebula are structures called Bok globules, small, dense clouds of gas and dust that appear as dark spots against the brighter background of the nebula. These globules are likely in the early stages of collapsing to form stars, small dark seeds of suns-to-be, hidden within the larger cloud. There is also a region within the Lagoon Nebula called the Hourglass, a small, bright region of complex, twisted gas created by a hot, energetic young star embedded within it. The intense stellar winds from this star are sculpting the surrounding gas into a dramatic shape, beautiful and turbulent. The Lagoon Nebula, visible with the naked eye from a dark field, yet containing within it all this complexity. Globules and clusters and sculpted gas and newborn stars. A world within a smudge of light. Everything, when you look closely enough. The light from some nebulae has been traveling toward us for thousands of years. This is true of essentially all astronomical objects. But with nebulae, it carries a particular quality. When you look at a nebula, even one relatively close to us, you are seeing it as it was, not as it is. The Orion Nebula, 1,344 light-years away, shows us what it looked like more than 13 centuries ago. The Eagle Nebula, about 7,000 light-years away, shows us what it looked like 7,000 years before tonight. And the Carina Nebula, at 7,500 light-years, shows us a snapshot from a time before the pyramids of Egypt were built. Looking at a nebula is looking into history. The photons arriving at our telescopes tonight left their source before the fall of Rome, before the invention of writing, before our ancestors first began to build permanent settlements. The light carries no memory of the journey. It simply arrives, having crossed that vast, dark distance at the only speed light knows, and lands on our instruments or on the retinas of anyone fortunate enough to be in the right dark field with the right telescope. There is something deeply peaceful about this. The universe does not rush its messages. They travel at the speed of light, which is the fastest anything in the universe can move, and yet the distances are so enormous that light years and centuries pass before they arrive. Tonight, light that left a nebula before you were born, before your parents were born, before many generations back, is arriving at Earth and being recorded. Ancient light, still carrying its message, still telling us what was. The Helix Nebula is the closest planetary nebula to Earth. It sits about 650 light-years away in the constellation Aquarius. For a nebula, this is remarkably close. The Helix Nebula is also one of the largest apparent planetary nebulae in the sky, spanning about 3 light-years across. In photographs, it is stunning. A great circular structure, the inner regions are cool blue-green from doubly ionized oxygen, surrounded by rings of red and orange from hydrogen. At the center, tiny and barely visible in ordinary images, is the white dwarf that created it. The helix has been nicknamed the Eye of God, and when you see an image of it, the name feels apt. The nested rings of color surrounding the bright central region do have a disconcerting resemblance to an enormous eye, gazing outward from the dark. Scientists have found complex organic molecules called polycyclic aromatic hydrocarbons within the Helix Nebula. These are large carbon-based molecules, thought to be precursors to more complex organic chemistry. They are also found in cold molecular clouds, in meteorites, and in the interstellar medium throughout the galaxy. They appear to be ubiquitous products of stellar and chemical processes throughout the cosmos. The Helix Nebula also has cometary knots. These are small, dense clumps of gas within the nebula, each one with a bright head pointing toward the central star, and a long, dimmer tail streaming outward. They look, in photographs, remarkably like tiny comets. There are estimated to be around 20,000 of them within the helix. Each one is roughly the size of our solar system. 20,000 solar system-sized objects inside one planetary nebula, each one shaped like a comet, each one a dense clump of gas shaped by the radiation of a dying star. The universe is not short on detail. It is intricate all the way down. The Omega Nebula, also called the Swan Nebula, is one of the brightest and most massive stellar nurseries in the Milky Way. It is located about 5,000 to 6,000 light-years from Earth, in the constellation Sagittarius. The Omega Nebula is an emission nebula, actively forming stars at an extraordinary rate. It contains a massive star cluster embedded within the cloud, whose radiation is heating and ionizing the surrounding gas to produce the nebula's glow. The nebula itself is breathtaking. In photographs, it appears as a long, bright bar of luminous pink and red gas, with a curved, dimmer extension that gives it its omega-like shape. It is thought to contain over 800 solar masses of ionized gas, plus a much larger surrounding cloud of cool molecular gas. And within that larger cloud, there are active regions of star formation happening right now. The Omega Nebula has been observed by most major telescopes. The Hubble Space Telescope produced images of its inner regions showing intricate filaments and columns of gas, dense knots of material that may be protostellar cores, and the general beautiful turbulence of a cloud being lit up from within by newly born stars. The European Southern Observatory has also photographed it in extraordinary detail, revealing layers of structure at its edges where the ionized gas meets the cooler molecular cloud beyond. The Omega Nebula is a factory, a vast, bright, busy factory of stars. And unlike most factories, it glows pink. It is beautiful in the way that productive things can sometimes be beautiful. Not despite the activity within it, but because of it. Light as a byproduct of creation. There is a nebula that looks like a running man. The Running Man Nebula sits right next to the Orion Nebula in the sky, so close that the two are often photographed together. In photographs, the Running Man Nebula, also catalogued as NGC 1977, 1973, and 1968, appears as a complex of blue and dark nebulosity. 3 young star clusters illuminate the surrounding gas from within, creating glowing patches and dark silhouettes. When photographed with longer exposures, the structure of the Running Man emerges. Dark bands and filaments of dust create a silhouette against the brighter gas, and with a little imagination, one can see the figure of a running person, leaning forward, mid-stride. It is a reflection nebula, glowing blue as it scatters the light of the young stars within it. The Running Man Nebula is often overshadowed by its more famous neighbor, the Great Orion Nebula. But in its own right, it is a remarkable object. A complex of gas and dust and young stars, active and glowing, making a shape that reminds us of ourselves. Running through the dark. Or perhaps, running toward something. The universe arranges matter into the shapes of things that interest us. And in a galaxy of 300 billion stars, it sometimes arranges it into the shape of us. A nebula, called the Boomerang, is the coldest known natural place in the universe. This is not a modest claim. Space itself, far from any heat source, has a background temperature of about 2.7 degrees above absolute zero. This cosmic microwave background fills the universe and sets a floor on how cold things can get in any location bathed by its radiation. The Boomerang Nebula is colder than that. It is a protoplanetary nebula, a cloud in an intermediate stage between a red giant star and a true planetary nebula, located about 5,000 light-years from Earth in the constellation Centaurus. The central star of the Boomerang is expelling gas at an extraordinarily rapid rate and at extremely high velocity. This rapid outflow causes the gas to expand and cool dramatically through a process similar to how pressurized gas in a spray can cool when released. The result is gas at a temperature of about 1 degree above absolute zero. 1 degree above the lowest temperature physically possible. Colder than the background radiation of the universe. In radio telescope observations, the Boomerang Nebula appears to absorb the cosmic microwave background rather than glow against it, the only naturally occurring object known to do this. It is a cold spot in the universe, a place of such stillness that even the background warmth of the cosmos is too warm by comparison. There is something almost meditative about that. A place colder than the universe itself. Beyond still. Beyond quiet. The deepest cold imaginable, drifting in the constellation of the Centaur. The Eagle Nebula contains regions where stars are forming right now. At this very moment. We have visited the Eagle Nebula already through the pillars of creation, but it is worth spending a little more time here. The Eagle Nebula, catalogued as Messier 16, is about 7,000 light-years away in the constellation Serpens. The Serpent. The nebula itself is a large emission nebula, about 30 light-years across. At its heart, an open cluster of young hot stars called NGC 6611 illuminates the surrounding cloud with intense ultraviolet radiation. The pillars of creation are the most famous feature of the Eagle Nebula, but the nebula is full of similar structures on smaller scales. Columns and pillars and globules of dense gas, each one potentially harboring a collapsing core at its tip. Some of these columns have already been eroded significantly by the radiation from the central star cluster. Others are newer, still preserving within them the dense concentrations of gas that will eventually become stars. Star formation in the Eagle Nebula has been happening for millions of years. The oldest stars in the central cluster are estimated to be about 5 to 6 million years old. The youngest stars, still embedded in the pillars, may be only 100,000 years old. 5 million years of star formation in one nebula. For context, 5 million years ago, our earliest human ancestors were just beginning to walk upright on the savannas of Africa. In the time that separates us from those first tentative steps on 2 feet, the Eagle Nebula has been making suns. Stars that now burn steadily in that distant cluster, 7,000 light-years away, all born from the same cloud, all carrying within them the chemistry of the nebula that made them. The galaxy's spiral arms are outlined, in part, by glowing nebulae. When you look at photographs of distant spiral galaxies, those graceful islands of hundreds of billions of stars seen from outside, you notice that the spiral arms are not uniformly bright. They have structure, bright knots and clumps, regions of intense brightness interspersed with dimmer stretches. Many of those bright knots are emission nebulae. Spiral arms are regions where the density of the galaxy is slightly higher than average, and as gas in the galaxy passes through these density waves, it is compressed and triggered to collapse into new stars. The hot, luminous young stars that form in these regions illuminate the surrounding gas, creating bright emission nebulae. These nebulae then glow brightly, marking the locations of the spiral arms from millions of light-years away. The arms we see in spiral galaxies are not made of specific stars that have always been in the arm. They are more like a pattern, a wave of density moving through the galaxy, like a traffic jam that persists even as individual cars move through it and out the other side. The nebulae within those arms are traces of the wave. They mark where the gas is being compressed, where stars are being born, where the galaxy is actively creating its own future. In our own Milky Way, the nebulae we observe mark the locations of our galaxy's own spiral arms. We are inside the galaxy and cannot see its grand spiral structure directly. But by mapping the nebulae and the young stars they produce, astronomers have been able to infer the shape of our cosmic home. We are, best as we can tell, located in a minor arm, sometimes called the Orion arm or the local arm, somewhere between two of the major spiral arms of the Milky Way. A small, nebula-lit edge of a large and beautiful spiral, spinning slowly through the cosmos. Our address. Our home. There is a nebula that exists beyond the edge of our galaxy. The Tarantula Nebula, which we mentioned earlier as one of the largest nebulae known, is located not in the Milky Way, but in the Large Magellanic Cloud. The Large Magellanic Cloud is a small irregular galaxy that orbits our own Milky Way. It is visible from the southern hemisphere as a fuzzy patch in the sky, like a detached piece of the Milky Way floating beside it. The Tarantula Nebula, also known as 30 Doradus, is located about 160,000 light-years away. It is so large and so luminous that if it were relocated to the same distance as the Orion Nebula, it would dominate the night sky and be bright enough to cast shadows. At its core is a dense cluster of massive stars called R136. This cluster contains some of the most massive stars ever discovered. Several of its stars have been measured at over 100 solar masses. A few may exceed 200 solar masses. These are not just large stars. They are at the absolute upper limit of what stellar physics permits. Each one burns with a luminosity millions of times that of our Sun. Each one will live for only a few million years before ending in a catastrophic supernova. The Tarantula Nebula was the site of one of the most observed supernovae in modern history. In 1987, a star in the outskirts of the Tarantula Nebula exploded. It was the first supernova visible to the naked eye since 1604, and it was watched in extraordinary detail by every major observatory on Earth. The remnant of that supernova, called Supernova 1987A, is still being observed today. It has formed a ring structure as the expanding shock wave collided with material previously expelled by the dying star. And it continues to evolve in real time, a living laboratory for the physics of stellar death. The Tarantula Nebula is too far away for most people to ever have seen, visible only from the southern hemisphere, and only as a part of the already faint smudge of the Large Magellanic Cloud. But it is there. The largest and brightest star-forming region in our cosmic neighborhood. A tarantula made of gas and light, 160,000 light-years away, spinning new suns into existence while you sleep. A nebula is not permanent. This is something that is easy to forget when looking at images of these vast and ancient-seeming structures. They look eternal. They look like things that have always been there, and always will be. But a nebula is a phase. A molecular cloud that is not currently forming stars will typically survive for perhaps 10 to 100 million years before being dispersed by the turbulence of the galaxy or before beginning to form stars. An emission nebula, actively glowing under the radiation of hot, young stars, may only remain in its current glorious state for a few million years. As the hottest stars age and explode, their radiation diminishes. The cloud cools and darkens. What was bright becomes dim, and eventually invisible. A planetary nebula disperses even faster. After forming, it expands and thins over roughly 10 to 50,000 years, until the gas is too sparse to glow. A supernova remnant expands at high speed and disperses over tens of thousands to 100,000 years, its filaments stretching thinner and thinner until they merge with the surrounding interstellar medium. Everything changes. The nebulae we see tonight are snapshots, moments in long histories. The Orion Nebula a million years from now will look nothing like it does tonight. Some of its current bright knots of gas will have collapsed into stars. The central trapezium stars will have lived and died. The whole structure will have dispersed and reorganized. We are seeing the nebulae in one particular moment of their long existence. And they are seeing us in the same way. A moment, a phase, something that has been before and will be again, but will never be exactly this. Brief things. Beautiful in the way that brief things often are. The light from some distant galaxies shows us their nebulae as they looked billions of years ago. This is one of the most astonishing capabilities of our modern telescopes, particularly the James Webb Space Telescope. When Webb images a galaxy 12 billion light-years away, the light it is collecting left that galaxy 12 billion years ago. The universe itself is only about 13.8 billion years old. So Webb is seeing light that began traveling when the universe was less than 2 billion years old. In those early images, astronomers can see star-forming regions in those ancient galaxies, bright clumps of emission nebulae, regions where young hot stars are blazing, star formation happening at prodigious rates in young, energetic galaxies that have not yet settled into the calmer Middle Ages of galactic evolution. The early universe was different from the universe today. Galaxies were smaller, more irregular, and often forming stars at rates that dwarf anything seen in the modern universe. Some of the distant galaxies Webb observes are forming stars at rates hundreds of times higher than the Milky Way does today. And inside those galaxies, the nebulae were vast and turbulent and bright. We cannot visit those ancient nebulae. We can only receive their light, 12 billion years after it began its journey. Messages from the universe's youth. postcards from before our sun existed. Before the Earth formed. Before anything familiar to us was born. The universe, writing to us from its own childhood. Some nebulae are part of larger structures called superbubbles. A superbubble is a vast cavity in the interstellar medium, carved out by the combined energy of multiple supernova explosions and stellar winds from many massive stars over millions of years. These superbubbles can span hundreds or even thousands of light years. Their walls are shells of compressed gas, glowing where they are dense and hot enough, dark and invisible where they are thin and cool. Our own solar system sits inside one. We are located within a region of the galaxy called the local bubble, a cavity in the interstellar medium roughly 1,000 light-years across. This bubble was carved out over the past few tens of millions of years by a series of supernovae from massive stars that have since died. The walls of the local bubble are regions of compressed gas and dust, and some of the nearest star-forming regions to us, including those in Orion, Ophiuchus, Perseus, and Taurus, are located on or near the walls of this bubble. The supernovae that created the local bubble may have compressed gas at its walls enough to trigger the formation of those star-forming regions. Death giving rise to birth on a scale of hundreds of light years. And we live inside the remnant of that process. The Earth moves through space, within a bubble blown by ancient stellar explosions, surrounded at its walls by the next generation of stars being born. We are not outside the nebulae. We are inside the story. We have always been inside the story. The nebulae of the universe hold within them the material for all future stars and planets and, perhaps, all future life. There is no new matter in the universe. Or rather, all the matter that exists now has existed since the early moments after the Big Bang. What changes is not the quantity of matter, but the form it takes. Hydrogen and helium from the Big Bang formed the first stars. Those stars fused hydrogen into helium, helium into carbon, carbon into heavier elements. At the end of their lives, they returned this enriched material to space, into nebulae. New stars formed from those enriched nebulae, incorporating the heavier elements into their structure. Around some of those stars, planets formed. On some of those planets, conditions were right for chemistry to become biology. And in one particular case, that biology eventually became something that could look upward into the sky and wonder about the nebulae. The nebulae that exist today contain the material for the next generation of this cycle. Gas that will become stars in 100 million years. Stars that will make planets. Planets that may, one day, harbor something that asks where it came from. The nebulae are not separate from life. They are the medium through which the universe explores its own possibilities. The cloud becomes the star. The star becomes the planet. The planet becomes the creature. The creature becomes the question. And the question looks up at the cloud. and the cloud looks back. There is a nebula called the Medusa, and it is the remnant of a star that collapsed into a dense core. The Medusa Nebula, catalogued as Abell 21, is located about 1,500 light-years away in the constellation Gemini. It is an old planetary nebula, very old, as planetary nebulae go. The gas has been expanding for so long that it has grown quite faint and spread across a large area of sky. In photographs taken with large telescopes and long exposures, the Medusa Nebula shows a complex tangle of glowing filaments, curved and streaming, reminiscent of the serpentine hair of the mythological Medusa. The filaments are remnants of the star's outer layers, expelled gently over thousands of years as the star transitioned from a red giant to a white dwarf. They glow faintly in hydrogen and oxygen light, a soft, quiet luminescence that requires careful observation to see. The Medusa Nebula was once misidentified. For years, it was thought to be a supernova remnant, the aftermath of a violent explosion rather than a gentle stellar exhalation. Only later analysis established it clearly as a planetary nebula. Sometimes the universe presents us with things that look like one kind of story and turn out to be another entirely. Violent or gentle, explosion or quiet letting go. From a distance, they can look the same. It takes closer examination, more careful attention, to know which kind you are looking at. The same is true of many things. Some of the most beautiful nebulae in the sky are entirely invisible to the naked eye. The Witchhead Nebula is one of these. It is located about 900 light-years from Earth, in the constellation Eridanus, and it glows with the reflected light of a brilliant nearby star called Rigel. Rigel is one of the brightest stars in the night sky. It anchors the foot of the constellation Orion, a blue-white supergiant burning with a luminosity roughly 120,000 times that of our Sun. The Witchhead Nebula sits just to the west of Rigel, bathed in its intense blue-white light. As a reflection nebula, it scatters this light back toward us, glowing a ghostly blue in long-exposure photographs. In those photographs, the nebula's shape is unmistakable. It stretches across the sky in a long, slightly curved form, with features that bear an eerie resemblance to the profile of a witch in a pointed hat, nose jutting forward, mouth open as if cackling. The Witchhead Nebula spans roughly 50 light-years in total extent. It is one of many reflection nebulae scattered throughout the Orion-Eridanus region of the sky, a vast complex of gas and dust that extends across hundreds of light-years and is associated with the Orion molecular cloud, one of the most active star-forming regions in our neighborhood of the galaxy. A witch in blue light, 900 light-years away, laughing at nothing, or perhaps laughing at everything. The universe, once again, arranging its matter into something that makes you smile. There is a kind of nebula called a reflection nebula that we have touched on already, but it is worth dwelling on the physics of it for a moment. Because the physics is unexpectedly beautiful, When light from a star encounters a cloud of fine dust particles, several things can happen. If the dust is thick enough, the light is simply blocked. This creates a dark nebula. But if the dust is present, but not overwhelmingly dense, the light can scatter off the particles. Scattering depends on the size of the particles relative to the wavelength of the light. Dust grains in nebulae are very small, comparable in size to the wavelengths of visible light. And for particles of this size, shorter wavelengths of light, the blue end of the spectrum, scatter much more efficiently than longer wavelengths like red. This is called Rayleigh scattering, and it is the same effect that makes our sky blue. When sunlight enters our atmosphere and scatters off the molecules of air, the blue component scatters in all directions while the red mostly passes straight through. Look in any direction other than directly at the sun, and you are seeing scattered blue light. A reflection nebula works the same way. Starlight hits the dust cloud and the blue component scatters toward us, giving the nebula its characteristic blue hue. And so, when you look at a photograph of the Pleiades, that famous open cluster of blue-white stars, and you see the faint blue haze surrounding the stars, you are seeing a reflection nebula in action. The same physics that makes our sky blue, operating in the space between stars 400 light-years away. The same physical law, written everywhere, in our sky and in the nebulae, consistent and patient. The universe using the same rules wherever you look. Astronomers sometimes find nebulae in unexpected places. There is a class of objects called high-velocity clouds. These are clouds of gas found in the halo of our galaxy, the large, roughly spherical region that surrounds the flat disk of the Milky Way. These clouds are moving at velocities inconsistent with the normal rotation of the galaxy. Some are moving toward the disk of the Milky Way at high speed. Others are moving away. Their origin is a matter of ongoing research. Some may be gas that fell out of the Milky Way long ago and is now falling back. Others may be gas stripped from nearby dwarf galaxies. Still others may be ancient material from the intergalactic medium, gas that has never been part of any galaxy, falling inward to join the Milky Way for the first time. One of the most famous is called the Smith Cloud, a massive cloud of hydrogen gas currently plunging toward the disk of the Milky Way. Astronomers estimate that it will impact the disk in roughly 27 million years, likely triggering a burst of star formation where it collides with the existing gas of the galaxy. The Smith Cloud is about 11,000 light-years long and 2,500 light-years wide. It is a giant falling toward us in slow motion. A nebula from outside the galaxy, pulled in by gravity, destined to become part of our home. In 27 million years, if anything is here to watch, there will be a great flash of star formation, where the Smith Cloud meets the Milky Way. New suns kindled by the arrival of gas from beyond. A gift from intergalactic space. Received slowly, in the fullness of time. The Flame Nebula burns beside the Horsehead. These two nebulae, the Horsehead and the Flame, appear side by side in the sky just east of Alnitak, the leftmost star of Orion's belt. The Flame Nebula is an emission nebula, glowing in the warm colors of ionized hydrogen. It gets its name from its appearance in photographs. A central bright region surrounded by darker lanes of dust give it the look of a roaring fire, with tongues of flame rising from a bright core. The Flame Nebula glows because it is being energized by Alnitak itself, one of the hottest and most luminous stars visible to the naked eye. Alnitak is a triple star system. Its primary component, a massive blue supergiant, some 380 times the luminosity of our Sun. Its ultraviolet radiation floods the surrounding region, energizing the gas of the Flame Nebula and causing it to glow. And right beside the flame, against a backdrop of brighter emission gas, rises the famous dark pillar of the Horsehead Nebula. The Horsehead is a dark nebula, a protrusion of cold, dense gas and dust extending from a larger molecular cloud below. Its characteristic horsehead shape is defined by the way the dark material projects against the glowing gas behind it. Together, the flame and the horsehead make one of the most photographed regions of the sky. Warm orange fire on one side, cool dark shadow on the other. Creation and obscurity, side by side. One burning, one concealing. Both beautiful. Both part of the same great cloud, in the same corner of the same galaxy, lit by the same brilliant star. Different faces of the same thing. There are nebulae so faint they were not discovered until the age of long-exposure astrophotography. For most of the history of astronomy, observation was limited by the sensitivity of the human eye. The eye is a remarkable instrument, capable of detecting individual photons in very dark conditions. But it cannot accumulate light over time the way a photographic plate or a digital sensor can. When you look at a star, you see it as it is in that moment. But a camera with a long exposure can gather light for minutes, hours, or even days, building up an image of something far too faint for the eye to perceive directly. The history of astronomy since the invention of astrophotography is in large part the history of the universe becoming progressively less hidden. Nebulae that were invisible before photographic plates revealed them. Galaxies that appeared only as blank sky to visual observers but blossomed into complex spirals on long exposure photographs. And now, with digital sensors cooled to minimize noise, with software that can stack hundreds of exposures and subtract the darkness between them, amateur astronomers with modest equipment can produce images of nebulae that rival the professional photographs of a few decades ago. There are faint nebulae whose existence was unsuspected until careful deep imaging revealed them. Integrated flux nebulae, faint clouds of dust illuminated by the combined light of all the stars in the galaxy rather than by any single star, appear only in extremely long exposures as ghostly wisps of light, subtle and enormous. The universe is not hiding. It has always been there, in full. We are simply, slowly, becoming better at looking. And with each improvement in our instruments, more of it comes into view. More light out of the darkness. More structure from the void. There is always more. The Trifid Nebula is divided into 3 lobes by dark lanes of dust. It sits about 5,200 light-years from Earth, in the constellation Sagittarius, not far from the Lagoon Nebula. In photographs, the Trifid is a striking object. Its central bright emission region, pink and red with glowing hydrogen, is cut into 3 sections by dramatic dark lanes of dust. These lanes radiate outward from the center of the nebula, dividing it into thirds the way meridians divide a globe. Above and around the emission region, separated by a gap, floats a region of blue reflection nebula, a separate part of the same cloud illuminated by a different, cooler star. And within the Trifid, there are details that only become apparent under careful study. Small dark globules dot the nebula, compact clouds of gas and dust that may be protostars in early formation. A jet of material has been detected shooting outward from one of the young stars inside the nebula, a protostellar jet of the kind associated with the very earliest stages of star formation. The Trifid Nebula is simultaneously an emission nebula, a reflection nebula, and a dark nebula, all 3 types coexisting within the same complex of gas and dust. 3 stories in one cloud, glowing, reflecting, concealing, all at once. The universe rarely tells just one story at a time. The light that makes nebulae glow has traveled incredibly long distances to reach us. But there is another kind of distance worth thinking about. Not the distance across space, but the distance across time. The light from the Orion Nebula has been traveling for 1,344 years. When that light left the nebula, the Islamic Golden Age was beginning in the Middle East. Charlemagne had not yet been crowned Holy Roman Emperor. The Song dynasty in China was centuries in the future. While that light was crossing the void between us and Orion, the Renaissance happened. The printing press was invented. The Americas were reached by European voyagers. Telescopes were invented. Steam engines. Electricity. Computers. The light from the nebula was traveling through all of that. Unconcerned. At the speed of light, through the vacuum of space, crossing the darkness while history happened down here. And now it arrives. Tonight, in the same moment that you are lying here, at the end of a day, in a world full of whatever filled your hours. Light from 1,000 years ago, arriving at the same instant as this breath, this heartbeat, this moment of rest. Everything converging, everything meeting. Here, now. The James Webb Space Telescope has transformed our understanding of nebulae. When it released its first images in July of 2022, the response was unlike anything in recent scientific memory. People who were not scientists, who had no particular background in astronomy, looked at the images and fell quiet. The images were that kind of thing. Webb's primary mirror is 6.5 meters across, nearly 3 times the diameter of Hubble's. And it operates primarily in infrared, which allows it to see through the dust that blocks visible light and to detect the light from very distant objects whose light has been stretched into the infrared by the expansion of the universe. Among Webb's early targets were nebulae. The Carina Nebula image, released as part of the first batch of Webb images, showed the edge of a star-forming region in extraordinary detail. Mountains of gas and dust, backlit by the glow of young stars. Hundreds of previously unseen stars revealed where before there was only darkness. The image of the Southern Ring Nebula, a planetary nebula about 2,000 light-years from Earth, revealed that the central star was not alone. Webb resolved a companion star, previously unseen, showing that the nebula was shaped in part by the gravitational interaction of 2 stars, not one. Webb has revealed that many planetary nebulae thought to have single central stars actually have binary companions. The companion stars shape the outflows of the dying star, influencing the structure of the resulting nebula. The universe is more complicated than we thought, and also more beautiful. Webb continues to observe. Each image a window, each window wider than the last. The universe, gradually, patiently, showing itself to us. There are nebulae forming stars that may have planets similar to Earth. This is a statement that would have seemed wildly speculative a few decades ago. The first confirmed detection of a planet around another star came only in 1995. Before that, we could not be certain that planetary systems were common. We know now that they are not just common. They are the rule. Nearly every star studied carefully enough has been found to have some kind of planetary system. The galaxy is full of planets. And so the nebulae that are currently forming new stars are also, by implication, forming new planetary systems. In the protoplanetary disks that surround the young stars of the Orion Nebula, planets are forming right now. Rocky worlds in some cases, gas giants in others, ice-covered moons, asteroids and comets. We cannot directly observe these forming worlds in most cases. They are too small and too close to their parent stars. But we can detect the disks in which they are forming. We can measure their sizes and masses and compositions. We can watch the gaps opening in some disks that suggest a planet has already cleared its orbit. And within some of those forming systems, at just the right distance from their star, in what we call the habitable zone, rocky worlds may be forming with conditions that could, eventually, over billions of years, allow for the existence of liquid water, of chemistry, of life. We do not know if any of them will. Life is not guaranteed by having the right conditions. We only know of one example where conditions led to life, and we are that example. But the nebulae are making the raw materials, the stars and the worlds and the chemistry. The rest, as always, is a matter of time. The Cone Nebula is a towering pillar of gas and dust rising from a larger star-forming cloud. It is located about 2,500 light-years from Earth in the constellation Monoceros, the Unicorn. The Cone Nebula is part of a larger structure called the Christmas Tree Cluster and associated nebulosity. The young star cluster above it forms the trunk and branches of a Christmas tree shape when the image is oriented in a certain way, and the cone projects downward from the base of the cluster like a dark pillar. The cone is roughly 7 light-years long. Its dark interior is a region of cold, dense gas, shielded from the intense radiation of the nearby cluster by the outer layers of the pillar. Within that shielded interior, star formation may be occurring, hidden from direct observation by the very material that is protecting it. The tip of the cone, the topmost point of the pillar, is being eroded by the ultraviolet radiation from the cluster stars above. The gas there is being heated, ionized, and blown away in a process called photoevaporation. Slowly, the pillar is being eaten from the outside in. But slowly is a relative term when you are talking about nebulae. The Cone Nebula will persist for millions of years in something close to its current form. The Hubble Space Telescope has produced striking images of the cone's tip, showing the region of transition between the cool, protected interior and the hot outer surface, where the radiation from the stars is stripping material away. A pillar of night, standing against the light, slowly eroding, but standing for now, holding its cool, dark center intact. Patient. The universe contains more than 2 trillion galaxies, and each one contains its own nebulae. 2 trillion. In each of those galaxies, the same processes we have been exploring tonight are happening. Molecular clouds collapsing into protostars, young stars igniting and illuminating the gas around them, massive stars reaching the ends of their lives and exploding into supernova remnants, old sun-like stars shedding their outer layers into planetary nebulae. In 2 trillion galaxies, simultaneously. The universe does not pause for sleep. It does not wait for an audience. It simply continues, in all its galactic proliferation, making stars and nebulae and the chemical elements of which everything is made. Somewhere in a galaxy far beyond the reach of any telescope we have yet built, there is a nebula glowing with the same colors as the Orion Nebula. Somewhere, a star is ending its life and forming a butterfly-shaped nebula with 2 great lobes of gas. Somewhere, a massive star cluster is eroding the pillars of its own nursery. The same story, written in hydrogen and light and gravity, repeated across 2 trillion chapters. We have only read a few sentences of the first one, and we are only just beginning to understand the alphabet. The universe is very large, and very patient, and very, very full of nebulae. There is a nebula called the Ghost of Jupiter. It is a planetary nebula located about 1,400 light-years from Earth in the constellation Hydra. Its name comes from its appearance through small telescopes, where it shows a bluish disk roughly similar in apparent size to the planet Jupiter in the sky. To early observers, looking through telescopes of modest power, it resembled a ghostly version of the familiar planet. Through larger telescopes and in photographs, the ghost of Jupiter reveals more detail. An inner bright region surrounded by a fainter outer shell, with hints of structure in between. The colors range from greenish blue to yellow, the contribution of oxygen and hydrogen lighting the gas at different temperatures. The central white dwarf that created the ghost of Jupiter was once a star similar to our Sun. It lived for billions of years, fusing hydrogen in its core, shining steadily. And then, at the end, it swelled into a red giant and gently expelled its outer layers to form the nebula we see today. The ghost of Jupiter is a preview, in a sense, of our own Sun's fate. In about 5 billion years, our Sun will do exactly what this star did. It will swell and shed, and leave behind a glowing cloud of its own expelled material. And that cloud will drift and thin for tens of thousands of years, and eventually be absorbed back into the interstellar medium, and eventually be gathered into new stars and new worlds. The ghost of Jupiter is our future. A beautiful, ghostly, perfectly ordinary ending. 5 billion years from now. But not tonight. Tonight, the sun sleeps below the horizon, and the stars are out, and you are drifting. The universe has one more quiet gift to offer before we let tonight carry you fully into sleep. It is this. Every single atom of hydrogen in every nebula we have visited tonight has been hydrogen since the beginning. Since the Big Bang. The hydrogen in the Orion Nebula, the hydrogen in the Crab Nebula, the hydrogen in the cold depths of the Boomerang, the hydrogen in the Tarantula 160,000 light-years away. All of it, hydrogen since the first few minutes after the universe began. 13.8 billion years. The same atoms, recycled through stars and nebulae and more stars and more nebulae, swapped between forms, passed between places, but never destroyed. The hydrogen in your body right now was part of the Big Bang. It was part of the first stars. It was part of nebulae long before our sun formed. It was part of the cloud that collapsed to become our solar system. It was part of the early ocean. It was part of creatures that swam, and creatures that crawled, and creatures that walked, and now it is part of you. And one day, in the fullness of deep time, it will be part of something else. Another star, perhaps. Another planet. Another ocean. Another creature wandering about the night sky. You are not passing through the universe. You are the universe passing through this particular shape, in this particular moment, for what feels like a very long time but is, on the scale of hydrogen, the briefest of rests. A rest, like the one that is coming for you now. We have come a long way tonight, you and I. We have drifted through hydrogen clouds older than any story we can tell. We have stood, imaginatively, at the bases of pillars 4 light-years tall. We have traced the delicate filaments of the Veil Nebula, the last breath of a star that died 5,000 years before tonight. We have learned that the nebulae are not simply beautiful backgrounds. They are the ongoing work of the universe. Its factories and its graveyards, its nurseries and its archives. The raw material of suns and the legacy of those long burned out. We have learned that some nebulae glow with their own light, and some reflect the light of others. That some are cold beyond imagining, and some are heated to millions of degrees. That some smell, faintly and impossibly, of raspberries. We have learned that you are made of nebula, that the atoms in your body were once gas drifting between the stars, that the iron carrying oxygen through your blood was forged in a star that lived and died before our sun was born. We have learned that the universe is not a distant thing. It is not somewhere out there, separated from us by cold black space. You are inside it, made of it, the nebula thinking. And now, as the thoughts slow and the breathing deepens, as the edges of the day soften and the night comes fully in, allow yourself to imagine the great clouds drifting overhead. Beyond the ceiling and the roof and the cool air outside, beyond the clouds of this planet, through the thin atmosphere and out into the dark. Past the moon and the planets and the other stars of our small neighborhood. Out into the galaxy. Into the nebulae. Imagine the soft red glow of hydrogen gas, vast and silent. The blue haze of reflected starlight on dust. The dark pillars rising into a lit sky. The delicate filaments of the veil, still spreading outward from an explosion that human beings saw 1,000 years ago. Imagine drifting through those clouds. No gravity pulling you down. No sound at all. Just the faint warm glow of gas on all sides. Stars forming slowly in the dark. The patient work of the universe continuing around you, as it always has and always will. You do not need to do anything here. You do not need to understand it, or measure it, or name it. You only need to drift. Like a molecule of hydrogen in a cloud, surrounded by other molecules, held loosely by the gentle pull of gravity. Slowly, 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 falling inward towards something luminous. If sleep has not yet found you, it is coming. Let the images from tonight drift as they will. The Orion Nebula, glowing pink above a winter sky. The Crab Nebula, still expanding from an explosion 1,000 years ago. The Butterfly Nebula, wings of stellar gas spread against the dark. The Boomerang, coldest place in the natural universe, quieter than space itself. Let them move through you like light through gas. Softly, without urgency. The nebulae are not going anywhere. They will be there tomorrow and next year and in a million years when none of us are here to see them. Their patient work of making stars will continue long after the last thought has faded into sleep tonight. There is something profoundly restful in that. The universe is handling it. You can let go. Close your eyes fully now, if you have not already. Let your body sink into whatever supports it. Feel the weight of your limbs, the warmth of the air around you, and let the nebulae drift above. Great clouds of gas and dust and ancient starlight, hundreds of light years across, moving through the dark at speeds our words cannot quite hold. You are small in the best possible way. You are small the way a single hydrogen atom is small inside a nebula. And yet you are part of the same story. The same enormous, unhurried, luminous story. And like all things in that story, you are exactly where you are supposed to be. Resting now. Breathing slowly. Drifting. Good night. And one more thing, before the last thought dissolves. The word nebula, which we began with tonight, comes from the Latin for mist or cloud. But in ancient Greek, the word Nephili meant cloud. And in the Greek myths, a Nebulae was sometimes a cloud being, a spirit of mist given temporary form. There was a story of a cloud nymph, summoned from the mist by the gods, given briefly the shape of a woman, and then returned at last to the sky from which she came. The scientists of the modern age did not know they were continuing this tradition when they began naming the clouds of the cosmos. But perhaps they were. The nebulae are clouds given form. Temporary forms. Shapes made of mist and light and the slow pull of gravity. Existing for millions of years, which on the scale of the universe is no more permanent than a cloud moving across an afternoon sky. And you. You are also a temporary form, made of mist and chemistry and the improbable collaboration of 100 trillion cells. Here for a little while in this particular arrangement. Breathing, thinking, wondering, and tonight, resting. Returning, for a few hours, to something like the deep quiet from which all things come. Sleep is not nothing. Sleep is where the mind returns to its source, where the body repairs and consolidates and grows quietly stronger, where the self dissolves for a time into something deeper and older and more restful than thought. The nebulae know this kind of rest. The dark molecular clouds, cold and still and dense, floating in the dark between the stars, not yet collapsed into anything, not yet glowing with the light of new suns, just existing in their potential state. That is a kind of rest too. Before the becoming, before the igniting, the deep, cold, patient quiet of a cloud that has not yet decided what it will become. You are like that now. In the space between today and tomorrow. Not yet tomorrow. No longer today. just resting in the dark and the warmth, breathing slowly, letting go of the edges of thought. The universe holds you. It has always held you. It will hold you through the night and into the morning, and for all the mornings after that. You are not separate from it. You never were. The same hydrogen that glows in the Orion Nebula is in your blood. The same gravity that pulls clouds together into stars keeps your feet on the earth. The same light that crossed 1,000 years of space to reach us tonight once landed on the face of someone who looked up and saw a smudge below Orion's belt, and perhaps felt what you might feel now. Small and held and part of something vast. Tired and safe and drifting. The nebulae are above you now. Beyond the ceiling, beyond the roof, beyond the thin, cool air of this planet. Out in the dark, glowing softly. Pink hydrogen, blue oxygen, dark pillars, glowing rings, butterfly wings of stellar gas, skulls of light, curtains of the veil, the quiet cold of the boomerang, the burning heart of the tarantula. All of it drifting. All of it yours to drift with. Close your eyes if they are still open. Let the breath slow one more time. In and out. And in and out. The nebulae are patient. They will be there when morning comes. They will be there in 100 years. They will be there long after all of this, glowing quietly in the dark. And right now, in this moment, so are you. Here, warm, at rest. Good night.